more nanoscale IR. So how far we see with the AFTIR, or all these are closely related with each other, or individually AFM and SNOM working together?
So the question is on SNOM. I only know a little bit about it, so I don't really have much to say. I haven't used it myself, so it would be hard for me to say. Yeah, I apologize. I can look up more. Yeah.
Then how far FTIR or AFTIR are linked together?
Same thing. I mean, these are techniques that I know that are emerging out of the labs, but those are more their method development is happening for those techniques, for the analytic techniques, as opposed to broad user availability. But I know what happens. I mean, the nice thing about, more generally, about material characterization techniques is that the companies have become strong, right? There's a lot of startup companies, small companies that were doing things like AFM and TEM to some extent. And now, now that there's such a good global user base for these things, I think those companies are becoming more and more healthy, and they're in a much better position to quickly adopt new discoveries than they were even 10 years ago. And so the companies are highly invested in these sorts of things. So if you say, I want to couple FTIR and AFM, they know there's enough competition in the marketplace now that if they don't do it as a company, that their competitor will. And so these laboratory realizations and discoveries and method developments are actually being translated to the marketplace much faster than they used to be. So it's a nice process to see from my perspective as a user.
Recently, sir, I joined a webinar, and they have asked me about the precursors for ceramic materials, and they just wanted to know from my side that AFTIR can work with those materials. So I am a bit confused about FTIR, AFTIR, and AFM.
Yeah.
So if you can.
Again, it's not I don't, those techniques, I think it's a more advanced technique, but I can look it up for you. AFTIR and so forth. I'd be happy to look into it for you. Yeah.
Sir, what is the difference between XRF and Auger electrons?
So Auger electrons are, we had it earlier in the talk. So Auger electrons are ones that are excited. I'm going back some slides. We can show it here. So what happens in an Auger transition is that you have both a relaxation and an excitation that happen in order to conserve energy. Auger will tell you about the material structure as well, but it's a much weaker signal, and so Auger spectroscopy typically is done, by in a way that is more difficult to to handle. So it's not as routine. If you look at our first chart, right? I think Auger is on this first chart. Yeah. Besides. Yeah, in here. Okay, so, and this is, again, giving you important elemental information, but it does not do it on a very, very small scale.
So the mechanism is almost same. You are taking the electron out, and the electron from the upper shell is taking the place, and the energy is released. You are measuring that energy.
Yeah.
So in both the techniques, you are doing the same thing.
Right. Yeah. Yes. But the Auger, so I think that certain elements have a stronger Auger signal than others, and so it's easier to pick up some by Auger than others, although it's not a technique that I use routinely. Yeah. Okay, if there are no more questions, I thank you very much, and it is now lunchtime. I was told to tell you to go have a good lunch, and we'll be back here at the next